So I'm Glenn Moyer, W1WGM from Westford. Not much of a ham radio guy, though I did sit for the exams and register a call sign. I'm a radar systems engineer by career, retired now. UMass Amherst, Microwave Remote Sensing Labs, where I did my graduate work. So I've worked in radar all but like 3 years of my career, where they were desperately in need of a communication engineer, and they transplanted me to communication systems. My show and tell, just by way of an introduction, is a little radar system, and it's an educational system. A colleague from MIT Lincoln Lab that we both worked on the space fence radar that recently, a big new radar that Lockheed Martin built and put out in Kwajalein. He had, his thesis work was on an FMCW radar, and when they were looking for a teaching toy, if you will, he came up with this. I met him on that project, and he was talking to some of us about it, and it's a cool idea. I could, mind if I appropriate that? He handed over the whole design and everything, and I redesigned some of the stuff, but stuck to the basic RFery. It's got two antennas, cantennas these are. They're coffee cans. And the students are employees of, in his case, MIT Lincoln Laboratory, an FFR, Federally Funded Research and Development Center. And I worked there the first 18 years of my career, went to a startup for a couple of years, time off for good behavior, they say, and then ended up at the other FFRDC in the region, the MITRE Corporation down in Bedford. Lincoln Labs is in Lexington. I just went like one town over to MITRE, and worked there for the last 15, 16 years of my career. And so basically it's a coffee can radar. I don't know if you can shoot inside there. The students in this class are employees. They're all basically engineers or technical people. I've had some mathematicians, physicists, engineers that have taken it. And the students basically build this whole thing that you see in front of it, including the cantennas, the coffee can antennas. They've got a little quarter wave monopole inside. The students have to cut that. You measure, there's a design, you measure it, cut it, and then we set them up with a network analyzer, and you basically tweak the thing until you get a minimum return loss. And that's how you know you got a good antenna. And so the course is all about kind of teaching them about RF and how things work and how radar works. And these are professional people that are managing programs for acquisition and delivery of radar systems. So they're the government's representatives for these big radar programs to help educate the government on what they're buying and where it's working or not, and provide educated advice. And so it was basically something to try to train them. A lot of them didn't have my background of working in a remote sensing organization. And it was all about basically teaching them what is a radar, how does a radar work. It's kind of, for even physicists and engineers that don't study electromagnetics, radar can be kind of confusing. It's a little complex, but this is basically trying to demystify it and put it in terms that they would be able to understand. So happy to answer detailed questions. It's real simple. It's the two 4 packs of AA batteries will keep this thing running for about 6 to 8 hours before they wear out. More than enough time to build it, get it all together, test all the individual components, integrate it, take it outside, and we do the building test. Basically, you set up in front of a big wall of a building and get about 100 yards away and turn it on and see if you can get a bounce off of the building. And so from there, we send them out to find interesting things. I've got a couple of charts here that show you a couple of interesting things you can point the radar at that will convince you it actually does work like a radar. So it's a fun project, recreational engineering for somebody who is grinding through the electromagnetics and the stuff that isn't quite as much fun, and kind of fun to turn other people onto this idea that you can see the world through RF eyes, if you will. There's another way, that's what radar's doing basically, is giving you another set of eyes at a wavelength that propagates through space, through weather, all weather, and whatnot.
What frequency is that?
It's in the, it's 300 megahertz of bandwidth at 2 point something to 2.6, so about 2.2 to 2.6.
Gigahertz.
Yes. And so it's in it's the band that is reserved for wireless communication. And I haven't powered one of these up in about 6 years now. The last time I taught the course was about 5 years ago. It was 2019 or 2018. And it worked in that allocation that was for wireless communication. They varied the limits on it. They had an update in the middle of all that. I will admit that we walked on bandwidth a little bit. It's very low power. It's about 4 milliwatts. And we operated basically at the MITRE campus. There's a huge area that's about a half a mile around, and almost all of our testing was done there on the rooftops of the buildings and things. So part of this was education about being good good neighbors for RF emissions. The power level's so low. I calculated power densities at the perimeter of that area, and was convinced that we would never interfere with anybody's system. And it's only a linear FM chirp, as opposed to you're competing against coded modulated signals that have a lot of signal to noise over interference. All of the little wireless things are technically interfering with each other, but they're all on their own coded channel. Anyway, happy to answer any more detailed questions, explain what the pictures are, what they mean. But by way of my introduction to the group, I'm a radar guy. I also have told Bruce and some others. My grandfather was very active in ham radio, W4 NRA at the end of his life. My dad, he had about the 2 tables worth on 2 sides worth of ham gear when I was a kid. I grew up at a young age visiting, staying at the weekend. He'd sit me down in front of one of the receivers with the knob, and I would chase carriers against. I learned later when I was in school in physics. The atmospherics, as the layers of the atmosphere you're bouncing off of bloom and swell and go up and down, chase it up in frequency, chase it down in frequency to try to keep a key signal, where I could try to pick out a couple of symbols. So I grew up exposed to this stuff, and probably is why I ended up going to a microwave remote sensing laboratory and working on remote sensing. So anyway, questions? Yeah, okay. Yeah, if you have any when you come up or you see the data and you're curious, happy to explain it.
Thank you.